Deep learning, a robust subset of machine learning, has played an integral role in the development of facial recognition technology, thereby transforming an array of sectors including security, social media, and consumer electronics. Offering a dynamic way to interpret large volumes of data in the form of faces, deep learning has marked a paradigm shift in how machines perceive and understand human identities. The history of deep learning and facial recognition can be traced back to the 1960s, when the earliest systems scanned faces via template matching. However, the results were often inaccurate. The term deep learning was first recognized in machine learning contexts in 1986. In the early 2000s, deep learning truly began to evolve in facial recognition, largely because it could handle larger datasets than conventional machine learning algorithms. Additionally, the advent of convolutional neural networks, CNN, a class of deep learning algorithms, revolutionized the science of recognizing faces. Deep learning's pivotal importance lies in its ability to perform automatic feature extraction from raw data, bypassing the need for manually programmed facial features. Moreover, deep learning algorithms develop hierarchical models which help identify faces under different lighting, expressions, and angles. As such, its performance on intricate recognition tasks has continually surpassed other methods, thereby amplifying its significance. Facial recognition is increasingly adopted in security and surveillance applications, like identifying prospective terrorists or locating missing persons. In consumer electronics, facial recognition is used for user identification to unlock devices, and in social media, it is used for tagging individuals in pictures. Furthermore, deep learning-based facial recognition algorithms empower healthcare industry, identifying genetic diseases using facial anomalies, tracking patient medication responses, and even predicting patient health risks based on facial features. Despite the undeniable benefits, deep learning in facial recognition is not without flaws. One major concern is the invasion of privacy. With the omnipresence of surveillance cameras, individuals may unknowingly be monitored without their consent. Additionally, algorithms might create a perceptible racial, ethnic, and gender bias, particularly if the training data is skewed. This brings an algorithmic discrimination into play, making certain groups more susceptible to misidentification and false positives. The facial recognition industry is also grappling with the issue of deepfakes, a term coined in 2017 to describe synthetic media where a person's image or video is replaced with someone else's likeness. This has opened the floodgates to a plethora of cybercrimes and scandals, posing privacy, security, and authenticity issues. However, in response to such concerns, stringent regulations are being laid out for responsible use of the technology. Developers, too, are expending considerable effort to minimize bias and improve accuracy. Hence, going forward, transparency, open dialogue, legal safeguards, and public sector participation are expected to shape the future landscape of deep learning and facial recognition. Despite the mixed feelings brought forth by deep learning and facial recognition, its impact remains undeniable, propelling a wave of innovation and convenience into numerous areas of our lives. From smartphones to border control, its presence is gradually becoming irreplaceable. However, as we continue to exploit its prowess, we must also be cognizant of the concerns surrounding privacy, biases, and authenticity, striving to develop and enforce policies that ensure its responsible use and evolution in the years to come. In essence, deep learning and facial recognition is a double-edged sword offering unprecedented capabilities amidst formidable challenges. It embodies one of the many testaments to the theme that pervades our digital age: the perpetual struggle between the transformative potential of technology and the ethical parameters of its deployment.